All right, let's take a look at Form A here. It says the Maclaurin series for the natural log of the quantity 1 plus x is given by the following. On its interval of convergence, the series converges to the natural log of 1 plus x. Let f be the function defined by f of x equaling x times the natural log of the quantity 1 plus x over 3. For part A, it asks us to write the first four non-zero terms and the general term of the Maclaurin series for f. So just focusing on part A here, I would start by copying down the most important thing from the introduction here. And so that is simply that for the x values, on the interval of convergence, these two things are equal to each other. And notice that they gave us the first three non-zero terms. And the general term. So now for building up this function right here, I would first use substitution to get the inside function to match. So natural log of 1 plus x over 3. And you could just replace all the x's with x over 3's. And how much you simplify is totally up to you. So it could look like this. It could look like that, or you could, simplify each of the x over 3 to powers and clean it up. So either way, I'll show two versions of the final answer. So one is where you have simplified. Let's see, I think that's 18 there. And then up to you what you want to do when the numbers get big. You could multiply it out, or you could hope it doesn't matter. So you could do something like this. And then that would be x to the n over 3 to the n times n. There you go. Anyway, and then the last thing I would do is multiply everything by x. And so you would get f of x is equal to x times the natural log of 1 plus x over 3, which would just be exactly what you had here multiplied by x. So it would be x squared over 3 minus, however you want to do this. I noticed some people really went for the unsimplified approach. And if you can live with yourself, then that's fine. Yeah, that's totally fine. Kind of hurts a little bit, but that's right. Let's see, how would I write that? Negative 1 plus 1 times x over 3 to the n. Whoops, that's supposed to be an n right there. N. You could have done that. You also could have written the simplified version by multiplying this by x. And that for this problem is my preference. That'll be x to the n plus 1 over 3 to the n. There we go. All right, I'll come back and talk about scoring in just a little bit. I mean, if you wrote instead of 4 times 3 to the fourth, if you wrote 324, then that's fabulous. Okay. Part B. Determine the interval of convergence of the Maclaurin series for F. Show the work that leads to your answer. I would start by saying the magic words. We enforce the condition of convergence of the ratio test. Now, this problem did not specifically use language that makes it so that this little tagline is necessary, worth points. But there, if they had said something like justify your answer or something like that, then you would need it. So I say just always have it. So we'll take the limit as n approaches infinity of the absolute value of the n plus 1 term, which would be -1 to the n plus 2 times x to the n plus 2 over 3 to the n plus 1 times n plus 1. And that would be multiplied or divided by the nth term, which is multiplied by its reciprocal. And since we're enforcing the condition of convergence, we're making this be less than 1. All right, now let's simplify this. So we'd end up with a limit as n approaches infinity. And when you simplify, you end up canceling out most things. So like these guys, these guys, and I think everything else will still be there. So we'd be left with -1 times x over 3 times n over n plus 1. You could, of course, write this in a number of different ways. From here, factor out the constant as far as the limit is concerned. The absolute value of x over 3 is a constant. You could have the negative in there as well. I hope it makes sense that -1 doesn't really need to be there because it's going to be absolute valued anyway. So wherever you put it, you're going to get the same answer. So, like for example, if it was right there, you're still going to get the same thing because the absolute value marks. So this is equal to 1. And so we're left with absolute value of x over 3 has to be less than 1. Now you're going to factor out the positive 1/3 out of the absolute value. And then you're going to multiply both sides by 3. Right there. Okay. And so the question was, they wanted to know the radius of convergence. That was part of it. And so you'd got that 3 there for your radius of convergence. So what does that mean? It means right now your interval of convergence at least includes everything from -3 to 3. All right, now since I'm using ratio test, we do want to make sure that we check endpoints. So for starters, let's check x equaling -3. We're just going to go back up to this. I would use the sigma version of the sum, and you're just going to replace x with -3. So you'd have the sum as n goes from 1 to infinity, and just go to that general term of what f of x was. So that would be -1 to the n plus 1 times -3 to the n plus 1 all over 3 to the n times n. Now, up to you how you want to simplify this. I personally blended these together. And so using a property of exponents, and I ended up with 3 to the n plus 1 over 3 to the n times n. And then from there, I was able to cancel n of the 3's. And then I was left with a 3 on top, which I could then factor out. And what do I have now? I have either a p-series or a harmonic series, however you want to look at that. And so the point is that it diverges. Okay, so we should keep this bracket a soft bracket. Okay, now let's check what happens when x is 3. When x is 3, we're going to get the sum as n goes from 1 to infinity of -1 to the n plus 1 times 3 to the n plus 1 over 3 to the n times n. Now on this one, I decided to cancel some of the 3's here. And so you'd have these 3's canceling out all but one of these 3's. And then from there, I factored the 3 out. And I was left with an alternating series. The non-alternating part is 1 over n, which is always positive, always decreasing, and approaches 0. So this is a convergent alternating series. All right, point is that this bracket right here should be changed to be a hard bracket in your final answer. So what that means is that the actual interval of convergence is x values, not including the -3, going all the way up to +3 and including the +3. There we go. All right, part C, let p sub 4 of x be the fourth degree Taylor polynomial for f about x equals 0. Use the alternating series error bound to find an upper bound for p sub 4 of 2 minus f of 2. So the first thing I'm going to do is copy down what f of x was, and this is a moment where I'm kind of glad that I did simplify it. Okay, and that's true for all x from -3 to 3. So basically, since f of 2, and imagine putting 2's in for all the x's up there. So you would have, whoops, it's f of 2. I don't want to show it really. But how do I know that f of 2 would be a convergent alternating series? Well, you can see it's alternating. And because 2 is in your interval of convergence, it would be convergent. So without having to think too hard, you could make that claim. So since f of 2 is a convergent alternating series, remember these words, they will help you. The difference between the fourth degree Taylor polynomial approximation at 2 and the actual value of f of 2 is less than, you could say the absolute value, or you could say the magnitude of the first, that's right, neglected term. All right, that is to say that the difference between p sub 4 of 2 and f of 2 will be less than the magnitude of, and your first neglected term would have been this guy right there. So that would have been minus 2 to the 5th over 4 times 81, which you of course can say whatever that is. Anyway, 324, I think. All right, let's see. So I'm going to go ahead and cancel this down just a little bit. So the 2's and the 4 can cancel, for example. And so you'd be left with 2 cubed over 81, which is just 8 over 81. Oops. There we go. And this would be the error bound that they're talking about. So the error is no bigger than 8/81, or is always less than that. All right, now for some scoring. Let me change my color here a little bit. Okay. Okay, so now for scoring, going all the way back up to the top. Okay, so they're going to give you, for part A, 1 point for the first 4 non-zero terms, which if you had it unsimplified, it could have looked like that as well. And then they're going to give you 1 point for the general term, which you could have had unsimplified as well. All right, for part B, they're going to give you 1 point for setting up the ratio. And so I'm just going to circle this part inside the absolute value marks. You also could have had a compound fraction, which would have been what I had before I flipped and multiplied. But they're going to give you 1 point for having anything equivalent to that mess right there. The next thing, they're going to give you 1 point for what they called computing the limits of the ratio. So that's where you simplified the left side, you let n go to infinity, and you got the absolute value of x/3 at some point in your work. The next point is for getting the radius of convergence correct. So having a radius of convergence of 3. Now that could show right here in your work, or it also could show here where your interval is, 6 units wide, centered at 0, so has a radius of 3. Next point is for considering both endpoints. Even if you messed it up, you get a point for considering them. And then the last point is for all this analysis on the endpoints and for getting the final interval of convergence, right? So it's basically for all of this. So you really had to work for that last point. Getting the analysis and the interval of convergence. Totally right there with that hard bracket on the 3, but a soft bracket on the -3. All right, now for part C, there are 2 points available for part C. 1 point is for using specifically the 5th degree term as your error bound. And then the last point is for getting that answer. There we go. All right, my friends, I hope this makes sense. Feel free to ask me questions if you have any. Take care, everybody.